everybody, this is Clint Hajar with NSCU 304, Brandman University. And this is week 4 heat presentation, where we're going to discuss some of the similarities, differences between heat, thermal energy, and temperature. Also, we will discuss about a little bit about what each one is, and we'll try to figure out what the main difference is probably the hardest thing. Most people seem to find the similarities between them pretty easily, but it's the differences that are a little harder. So, heat. Heat is when you have energy moving from an area of high temperature to low temperature. Flow of thermal energy from one place to another. Those mean the same thing. So, when you have something, say like the sun, which is a lot hotter than the earth, its heat flows from it to us, not the other way around. That's what heat is. Heat is something that is warmer, giving off to something that's cooler. And so here we made a little example about frying an egg and some bacon. So the heat is transferred from the flame to the pan to the egg. So this is the hottest. So it's not the pan. The pan isn't giving heat to the flame. It's the flame giving heat to the pan, which in turn gets hotter than the egg. So heat is transferred from the pan to the egg, bacon. Okay. Next up, we're talking about thermal energy. That's the energy inside matter. The greater the temperature, the greater the thermal energy. It's a combination of potential and kinetic energy. Everything has thermal energy. A grain of salt has thermal energy, but usually the thermal energy is higher in things that are hotter. So the higher the temperature, the more thermal energy there is. Thermal energy is somewhat what is stored. It's energy that's stored inside of an object, rather than being given off. Hot tea has more thermal energy again. Yeah, so like hot tea has more thermal energy than a cup of ice water, and that's so it can give off more energy. That's the important thing, is it could give off more energy because it has higher temperature. So that's what thermal energy is. Temperature is a measure of the average kinetic energy of the molecules of a substance. So in this situation here, we got a blow dryer, and it's blowing this air into this person's hair. And we can measure the heat of the air. So the temperature is a measure of heat. It is a way to measure heat. And speaking of measuring heat, we got three common measures of heat. One is the Celsius scale. It's to measure temperature. This is the Celsius scale. Is assumed that we're at atmospheric pressure, and it was created by Anders Celsius. He lived between 1701 and 1744. This scale was adopted in 1948, and it sets water's freezing point at 0 degrees and water's boiling point at 100 degrees. Next up, we got we got a formula here. This formula here, you plug in what you want for Celsius, or what you have for Celsius, and you can get Fahrenheit, or you can do, you can plug in whatever you got for Fahrenheit and get your Celsius. Just do some simple algebra. Celsius is used almost all over the world, except in the United States. We typically use Fahrenheit. which was invented by Daniel Gabriel Fahrenheit, and he lived between 1686 and 1736. This measure was introduced in 1724. It's used most commonly in the United States, and this is almost the same formula as the one from Fahrenheit. It's just the math's a little somewhat inverted. You could plug in what you want for Fahrenheit. You can get Celsius. You can plug in whatever you want for Celsius. You can get Fahrenheit. Just do the algebra and you'll be good. Kelvin is mostly used in laboratories and when conducting experiments and stuff like that. Maybe like engineering papers and lab reports. That's where they'll use Kelvin the most. It was first used around 1848. It was invented by William Thomson, who went by Lord Kelvin. The formula is right here. You take your degrees in Celsius, add 273.15, and you get your Kelvin. And it is important to know that Kelvin does not require the degrees symbol. Another side note of Kelvin is that at 0 degrees Kelvin, the life stops on Earth or in the universe. So that's another cool little fact about that. Heat, thermal energy, temperature, they're all related from the idea that heat is movement of thermal energy from an area of higher temperature to an area of lower temperature. All three are dealing with energy and energy transfer. That's how they're similar. Some of the differences between the three are that heat is equal to the energy transmitted. Thermal energy is like energy stored, and temperature is a measurement. So that's how they're different. And they're we go from here. We drew a little cycle of heat measured. You measure the heat. You get temperature. Heat's given off. We read it in temperature. There's thermal energy. Thermal energy gives off heat. And it's just a circle. It's kind of like a circle of heat right there. Here's our references page. You can go ahead and pause your video. Check that out. I want to thank all those people for contributing. And we want to thank you for sharing your time with us. This was NSCU 304 at Brandman University, and I'm Clint Hajar, and we'll see you guys next time. Thank you.